Welcome to Term Science. Today's topic is about introduction of gas turbine engines. First, we will discuss the name of gas turbine engines. Engine. Engine is a energy conversion device. It may be thermal energy to mechanical or chemical energy to mechanical. Turbine. In gas turbine, turbine is a device which used to produce power, which means turbine is a power producing device. Gas. The working medium is remains in gaseous phase throughout the entire cycle. That's why we call gas turbine engines. We will see history now. The theoretical gas turbine cycle was proposed and patented by Englishman John Barber in 1791, but the practical engine was patented by George Brayton in 1891. The first gas turbine implemented using piston cylinder compressor and piston cylinder expander. Gas turbine consists of three major components that are compressor, combustion chamber and turbine. We will see one by one. Compressor. Compressor is a device which used to increase pressure of gaseous medium. Here gaseous medium is air. In gas turbine, compressor acts as open system in which energy and mass can cross boundary of the compressor. Compressor is a work consuming device so that electrical energy or shaft work is necessary to run the compressor. Similarly, air enters the compressor at low pressure and leaves at high pressure. The cross-sectional area of axial flow compressor is decreased in order from entry to exit, which means area decreases from entry to exit. Hence, it is represented as like this in gas turbine: inlet, outlet. In axial flow compressor, n number of rotor and stator blades are mounted on the shaft, which increase pressure of air. The axial flow compressor may be single stage or multi-stage. Next, combustion chamber. Combustion chamber is also known as burner or flame holder. The outlet of compressor is connected to inlet of combustion chamber so that high pressure, high temperature air enters into combustion chamber where fuel is added to it. The multiple fuel injectors are placed at the entry of combustion chamber where it injects the fuel and create turbulence at the entry point. Due to turbulence, fuel and air mix thoroughly and ignited with help of spark plug. The combustion takes place at a high pressure and high temperature, which results increased in enthalpy of air. The process occurs in combustion chamber is considered as constant pressure process as it acts as open system. Next, turbine. Turbine is a work producing device by extracting high enthalpy of hot gases. This high pressure and high enthalpy of hot gas from combustion chamber enters the nozzle where pressure energy is converted to kinetic energy, which means pressure is decreased and velocity is increased. This kinetic energy impulses the turbine blade to rotate shaft and produce work. During this process, high pressure gases expand to low pressure. Turbines are generally classified into impulse turbine and reaction turbine, but in gas turbine only impulse turbine is used. In impulse turbine, there is n number of rotor and static blades are mounting on the shaft which extract the hot gas and produce work by rotating shaft. The cross-sectional area of the turbine from entry to exit is increasing order, which means area increases from entry to exit. Hence, it is represented as like this in gas turbine. This is the entry point, this is the exit point. Now we will combine all together. Initially, air enters into air filter where dust particle is removed and then enters into compressor. In compressor, air is compressed from low pressure to high pressure. We know that pressure is directly proportional to temperature. Hence, temperature is also increases. Then enters into combustion chamber. In combustion chamber, fuel is injected with help of fuel injectors where air and fuel gets mixed thoroughly. The air fuel mixture is ignited with a spark from spark plug, which result in increased enthalpy of the air. This high enthalpy gases enters into turbine where it impels turbine blade and rotate the shaft to produce power. After that, gases expelled to atmosphere if it is open gas turbine engine. We can generate the power by coupling generator to turbine output shaft. Whatever power produced by the turbine that is used to run the compressor, maximum 70 to 75% of power will be consumed by the compressor itself. In next class, we will see difference between gas turbine IC engine, gas turbine EC engine. Thank you. If you like this video, share, like, subscribe. Thank you.